All right, so welcome back. We are going to finish up the final exam review. Number 13 says Tynesha is solving the equation. What should she get as her solutions? Remember, we just factored this one up there. So I believe it was x plus 2 and 3x. Oh no, it was x plus 1 and 3x. X plus 1 and 3x minus 2, because foiling it out is 3x squared minus 2x. Oh, it was this right here. Because this foiled out will give us the same result. 3x squared minus 2x plus 6x, so 4x minus 4 is equal to 0. It says what should she get as her solutions? Remember, you can put that in Desmos and get the x-intercepts if you'd like, or just do it the easy way. X plus 2 is equal to 0. From here, we just move 2 to the other side, and x is equal to negative 2. And 3x minus 2 is equal to 0. Move the 2 over. We get 3x is equal to 2. Divide each side by 3 to isolate the x. So then we get x is equal to 2 over 3. So our zeros are x is equal to negative 2 and 2 over 3. Okay. Number 14. Which expression is rational? Looking over these again. Let us review the definition of a rational number, or an irrational number rather. An irrational number is any number that cannot be written as a function. I mean, as a fraction. So we know pi can't be written as a fraction. Pi plus pi can't be written as a fraction, so this one is irrational. The square root of 12 times the square root of 3 would give us square root of 12 times the square root of 3 gives us 6. 6 can be written as a fraction. This is rational. Square root of 6 minus the square root of 6 will very clearly give us 0. Same thing as saying a minus a is equal to 0. So this is rational. And 1/2 plus 3 over 5 are two fractions being added together. So clearly those can be written as fractions, and those are rational. All right, number 15. Simplify the expression. Like I said, I apologize if I'm teaching this in a way that wasn't taught to you guys, but I've always seen, or the way I know how to solve this is when you square something, so x, when you take the square root of something rather, you get x, square root of x is the same thing as raising it to the 1/2. So we'll take this whole expression and raise it to the 1/2, so we get 392 and 7 and 2 raised to the 1/2, and that just means you multiply across, so we get 392 raised to the 1/2 n to the 7 over 2, because you multiply when you're doing an exponent times an exponent, and then m is 2 over 2. Any whole numbers here you pull out, and then any numbers that stay with a half will stay inside the square root. So the square root of 392, all we have to do, and I like to do it this way if you have access to a calculator, is you just take y equals x squared, and we see if we can just pull out a handful of roots from here. Because an example of simplifying a square root is like the square root of 8. The same thing as saying 2 root 2, right? And actually, let me change the color on this. That way it doesn't confuse you guys. So square root of 8 is the same thing as saying 2 root 2. That's because inside the square root of 8, we have 4 times 2, right? So if you take the square roots individually, we have square root of 4 times the square root of 2, which shows you the square root of 4 is 2. And the square root of 2 can't be simplified any further, so that's why you get square root 2 over 2. So let us look for numbers in 392 that we can possibly take out. So it looks like in terms of squares, the biggest term we can take out is 196, right? So let's see if 392 is divisible by 196. So 392 divided by 196. It is. So let us think of 392 as, and I'll shift this over here. Square root of 392 is the same thing as saying the square root of our factors were 196 times 2. So square root of 196 times the square root of 2. And then I'll leave 7 over 2 over here and m2 over 2 over here. And what's the square root of 196? Clearly it's 14 squared. So we can simplify the square root of 196 to 14. And then the square root of 2 cannot be simplified any further. And then over here, we're just pulling out all of the square roots that we can. So 7 over 2 is the same thing as saying 3.5, right? So we have 3 wholes and a half. So that means that we're pulling out n to the third can be pulled out of that one. And then n to the half, since it's the fraction that's left over, that will be the half that is left inside the square root. And then m to the 2 over 2, 2 over 2 simplified is 1, so that's just going to be m to the first power. So everything inside a square root, aka this and this, will stay in a square root, and then everything that was pulled out we can leave out. So our simplified form is 14n to the third times m, and then everything that stayed in the square root was 2, and there was an n. And I'll show you guys one more time. This went over here, and this went over here, or under the square root. Okay. 16. Which of the following graphs represent the solution set? Remember, if we just plug this into decimals and compare, the most important thing is that we want this to be a y equals scenario. That way we can just read it a little better. So we have x plus 3y is less than or equal to 6. Let me just confirm that I got that right. Okay. So we want y by itself, right? So we move the x over, just like, like any equation, y is equal to x something, something, something. So move the x over, then we get 3y less than or equal to 6 minus x. Now all we have to do is get rid of the 3. So you just multiply by 1 over 3 on this side, and then you multiply the whole side over here by 1 over 3. So we get y is less than or equal to 1 over 3 times 6 is 2. And then 1 over 3 times 1 is still 1 over 3, so negative 1 over 3x. And remember, slope is rise over run. So that means for this graph, and since it's going to be negative, every time you rise 1, you have to run over it 3. So from here, we can just look at our graph, plug in 0 to get the y-intercept. So the y-intercept is 0, 2. And then we're going to So like if 0 over 2 is right here, and it's negative, now it's going to be a negative rise. So you go down 1 and then over 3. So 0, 2, looks like they all have the same y-intercept. And then you got to go, and for every time you go down 1, you got to run 3. So our answer is going to be A, because it says less than or equal to, so that's why the shaded area is going to be under the line. Okay, 17. Francia is buying pizza and breadsticks for her party. Her mom says that she can spend no more than 85. Each pizza costs 12. Breadsticks cost 7. Says write an inequality that represents the number of pizzas and breadsticks she can buy. This is a simple inequality, but let's write down our key facts. Pizza, $12. Breadsticks, $7 a piece. And our limit is $85 max. So that means that if pizza costs 12, it would be 12 times the number of pizzas you buy plus 7 times the number of breadsticks you buy, and this must be less than or equal to $85 because that is our limit. And that is as simple as it gets. Remember, X is the number of pizzas, so if we're just following the question, just replace P for X, and then breadsticks for Y, and that is the solution to 17. Number 18. Anthony will spend 42 max. Food is 7, game is 3. What is a combination that you can buy? So remember, $42 is our max. Food is 7. So games are 3. So that means $3 times the number of games plus $7 times the number of food you buy must be less than or equal to $42. And that is how you set up that one. Number 19. Oops. Linear parent function is shown below. What is the end behavior of a function? End behavior just means that as x approaches infinity, you want to see where the function will go. And as y approaches infinity, where does it go? And then the other side is obviously as x approaches negative infinity, where does the graph go? And as y approaches negative infinity, where does the graph go? Here, as x approaches infinity, x still goes towards infinity, still goes towards positive infinity. And as x goes to negative infinity, this one is going to negative infinity clearly. And it looks like the same is true with the y value. So the y value will always, as the y value increases, it will still head towards positive infinity, and this one heads towards negative infinity. Okay, question number 20. Sarah is saving money to buy a new phone, starts with 50, saves an additional 30 every week. Write a sequence. So our sequence is, so she starts with 50, right? And when you're writing an equation, the biggest thing is when the input is 0. So when input is 0, we know that y is equal to 50, right? Because the add initially means x is equal to 0, so whatever you plug in for your input, 50 is going to be your output. That's the biggest thing that you should take away from trying to solve this. And then it says she saves an additional $30 each week. So as long as we don't attach a variable to the 50, we will be fine. So it would be y is equal to 50 plus some number times x for each week, right? And obviously it says she saves $30 each week. So if we put 30 here, after the first week, x is equal to 1. So it would add 30, and on the second week it would add 60 because 30 times 2 is 60. So that is how you would write a sequence for number 20. Number 21. This one is really important. Jackson and his friends will buy at most 8 snacks at the movie theater and spend no more than 42. They will pay $4 for each box of candy, 7 for each box of popcorn. Write the inequalities and let us write down the most important things that we know. $42 is our max. Candy cost $4 and popcorn cost $7. So the first inequality, also I forgot to write what the first inequality was, at most 8 snacks, right? So 8 snack limit, which means that the addition must be less than, and for writing these on your own, try to start from the ground up and see what you have to multiply by. If you have to multiply by anything for writing inequalities. So like, let's say we get 2 bags of popcorn plus 5 boxes of candy. We wanted to test to see if that was less than or equal to 8, right? We know, obviously, that this is just quantity, so 2 plus 5 is less than or equal to 8. And when we look at this again, we realize, did we have to multiply 2 by anything? And did we have to multiply 5 by anything to get 2 and 5? And the answer is we did not. So this is a 1 here and this is a 1 here, right? So that means that when we plug in P is equal to 2 and C is equal to 5, and we're multiplying 2 by 1 and 5 by 1. So the first inequality is going to be P plus C is less than or equal to 8. And the second inequality, we know our limit is $42, so less than or equal to. And then, like, let's just test one. Like, let's test 2 and 5 again, right? So popcorn cost $7, candy costs $4. So 2 times 7 plus 5 times 4. 2 times 7 is $14 plus 5 times 4 is $20, and that is less than or equal to $42. And then we look at this and we say to ourselves, for this one, we said C is equal to 2. P, my bad. P is equal to 2. C was equal to 5. So we plug 2 right here, and we plug 5 right here. So what did we have to multiply by to get the solution? And the simple answer to that is 7 times your p-value plus 4 times your c-value will give you the price. So our two equations set up are going to be these right here. And that is the solution to number 22. And that concludes our review of the final exam. Sorry for uploading this so late. And I hope this helps, and good luck on your exam tomorrow.